Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about noise management. Ultimate noise management, probably no such thing. I should probably put that in quotes, and I think after we walk through this example, you'll see why. But let's do a little defining of situations here so you get an idea of what we're going to talk about. Sound is air transmitted. So we know that sound goes through the air and then it strikes our structure here. Well, this energy here that goes through the air and then strikes our structure is converted to a different kind of energy. Now, I want to be careful with the way I say this, but it's not different, it's just more unique in its signature. Okay, frequency response stays pretty close. It's just that the amplitude of the response is reduced. And naturally, since you're going from air through a solid here, we're going to get different signatures, okay? But it doesn't matter to the end result. The end result is attenuation. So whether the energy's coming through the air and striking one of our surfaces of our room or something else going on, the bottom line is we have to attenuate or we have to drain the energy out of it. So when we go through this process, when the energy goes through the air and it strikes a structure, we go from an airborne situation to a vibrational acoustic situation. Now, the sciences between airborne energy that we deal with every day in small rooms or large rooms versus the science of vibrational acoustics, it's pretty similar, okay? We have frequency response. We have all kinds of the same things that we go through with air and solids. But the signatures are different and the treatments are vastly different. There's a big difference between treating middle and high frequencies with open-celled foam than treating low frequencies in terms of barrier technology, the garbage truck that's in your mixes, okay? Who picked up the garbage when you're trying to do a mix and that 30 cycle and 40 cycle rumble comes through your walls into your mix. So a little bit different approach, and the key to understanding the difference between airborne acoustics and vibrational acoustics is in the overlap of the two disciplines. So that's what we have to, and that's where people get confused. They use airborne technologies to deal with structural issues that you just can't do. So how does it work? Well, when we're dealing with structures, I'm going to use an example of a truck ramp on a freeway. We've all been driving in the mountains, most of us that live in the Southwest. And to the side of the road, you're going to see a ramp, usually 45 degrees, some 30, where a truck, if he loses his brake going down a decline, you see the grades, 8 degrees, 9 degrees, 12 degrees I've seen sometimes. So if a truck loses his brake going downhill in a mountain, he can pull off onto this ramp. And what happens is the ramp bleeds the energy as he goes up. So it dissipates the energy from the truck or the speed. Now, if he's going really fast and he's still going too fast at the end of the ramp, there's usually water or sand he can impact, and that'll definitely reduce the energy of his forward movement. So when we're talking about vibrational acoustics and structures, our goal is to drain the energy just like a truck ramp drains the energy for a semi on a bad situation. So how do we do that? Well, every day I hear people calling me and tell me, well, I'm using that double drywall resilient clip approach. Okay, that's one method. There's numerous others. And believe me, it's not the only one, and it's probably of all of them the least effective. So be very, very careful with this, because this resilient clip thing really just works above 125 cycles. If you've got low frequency energy, it's not going to help. So I wanted to give you an example of a technique that we use in our builds. We don't use it too often because it's very expensive, but I want to use it as an example to illustrate noise management, and I also wanted to use it as an example of how powerful low frequency energy is. So what we do is we use poured concrete. We've poured 8-inch slab concrete for the walls. But the key here, since we're trying to isolate back to our truck example, and drain the energy from the vibration, we put these walls on separate foundations. So we have separate foundations isolating 3 walls, which are acting as one. Airspace between them calculated depending on frequency. Thickness of wall calculated depending on frequency of the barrier we require. I built one of these recently in Tucson, and it was really quiet in the room. We got down to 27 dB SPL at midnight, which is almost low enough you can hear your blood going through your heart, so to speak. You can actually feel and hear your heartbeat. But we were still able to measure 30 cycle energy on the other side. After 3 8-inch poured concrete walls with a 6-inch airspace between them and separate foundations, we still had a little bit of low end bleed. So that'll give you an idea of how powerful low frequency is. If 3 poured concrete walls of 8-inch with 6-inch airspace between them can't stop all the energy, what chance do you have with drywall and green glue? So be a little careful about what you're doing. Know what you're trying to do. Know the numbers. With noise, you have to measure. You have to quantify and qualify. You got to know the frequency, and you have to know the amplitude, the strength. Makes sense. You want to know how fast that truck's going in order to calculate angle to bleed the energy and distance, okay? So just to give you an idea, this is kind of the ultimate in noise management. Very expensive to pour 4 walls, and a ceiling of that concrete. So hope this helps a little bit, give you a feel for noise and the difference between structural transmission of noise and airborne energy. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.